Welcome to the Permaculture Orchard module, and in this module we're going to be exploring all the details around the creation of a permaculture orchard, the management of it, and all the considerations around increasing fertility, creating nice integrated systems between plant guilds and compatible grazers, the selection of plant species and the compatibility between them to create beneficial guilds, and the selection of good grazers that will be compatible to those plant guilds, and over time how they change, and suitable management techniques, and the management of fertility through compost teas and foliar sprays, and how we can organise the layers of an orchard to increase productivity and to create nice beneficial interactions between those layers of plants, and how we can best manage the design and the management of a permaculture orchard for commercial operation. So lots to cover. Initially, if we have a look at plant guilds, so a plant guild is a group of compatible plants that function together of mutual benefit to each plant. So if you think about in a forest environment, the plants have adapted to live alongside each other. They're not all compatible. Some plants have adopted, they're called allelopathic chemicals that they put into the soil to deter other plants, so that they try to hold on to a position in that forest and avoid competition by actively repelling other plants. But a lot of plants instead will cooperate with each other and help create conditions in their environment and within the soil that will be of mutual benefit to each other. And it's those plants that we're most interested in, the ones that will work together, compatible in incompatible guild organisations, and we can replicate those guild patterns in our agricultural production. So what we're looking for is an environment that's changed above the soil and below the soil by these plants. So this is the above ground. And there's a couple of different patterns in here. So if we look at below soil, you have different plants that have different effects within the soil. So you may have plants with nodules on their roots, and these nodules act as home for nitrogen fixating bacteria, and we call these nitrogenous bacteria. And they live in the root nodules. And what they can do is they can take atmospheric nitrogen out of the air, and they can fix it into soil nitrates that they will then feed the plant in exchange for the sugars that the plant feeds the bacteria. So it's a cooperation, a mutually beneficial cooperation between the bacteria and the plants. But by bringing that nitrogen into the soil profile, it's also making it available, because other things will eat those eat the roots. The roots might die back as this tree is grazed upon, or the roots are grazed upon by different soil microorganisms. So these nitrates will get into the soil profile and benefit the other plants that can take it up. You might get other plants that are nutrient accumulators. So they are good at sending down big taproots, gathering nutrients from deeper in the subsoil layers and bringing it up to the plant to give it a competitive advantage over other plants. But in doing so, it's also providing those nutrients within its tissues. So if those tissues are eaten by grazers in the root zone or in the forest zone, those nutrients will be returned back into the soil. So again, indirectly, they're making nutrients available in the soil. And you're also getting these hyphae connections with these plants between multiple plants, and these soil hyphae can span hundreds of kilometers through a forest. So these are the fungi hyphae, and they deliver nutrients and minerals to these plants in exchange for sugars. And the plants that are providing these exudates to these hyphae in exchange for these nutrients and minerals are attracting the fungi hyphae within that environment, and the presence of those soil hyphae is beneficial to other plants, which will also benefit from those interactions with the soil hyphae. So again, indirectly, you might have a plant here that's busy interacting with all these soil hyphae to collect all these nutrients from the soil hyphae for its own benefit. But by creating this environment with lots of soil hyphae in it, these other plants will benefit from it too by having access to that soil hyphae network, and also being able to exchange with the soil hyphae the nutrients that they have in exchange for the minerals and nutrients that the soil hyphae have. So you get these diverse interactions between plants, and often they're doing it for their own benefit, but as they're eaten or as they are modifying the soil environment, those actions will benefit the other plants in the immediate environment too. And you get the same sort of processes happening above ground. So you can get the modification of the habitat, so you can get patterning of the profile of the soil in a way that helps lift up the wind up and over the forest, and removes the energy of the wind as it moves through the forest. So it's creating habitat within this forest that will benefit the other trees in it. So you get creating beneficial microclimate, and it can create a warmer condition in that microclimate, and a moister condition. So it's warmer and wetter. There's less wind. There may be beneficial plants and animals that are in this system. So they might not necessarily be good for all the plants because they might be eating the plants, but by eating some of the plants and then returning a lot of those nutrients back into this ecosystem in their feces or their poos and wees, they are making those nutrients available to the other plants in the system. So this recycling of nutrients and matter in the system by different animals and insects eating the plants and each other, creating this constant turnaround of nutrients within the system that the plants will benefit from by being able to absorb those nutrients out of the soil as they're deposited into the soil. So you're getting nutrient cycling through the food chain. And you're also getting these plants help shade the soil and add debris to the soil, which is creating a nice layer of mulch and shading the soil, which will benefit the microorganisms in the soil, which will then benefit the plants. So you're getting an improvement in soil habitat and quality through mulches and shading. So accumulatively, you're getting all of these multiple benefits from these plants working together. And they may not be doing it intentionally, but because they're co-evolving together, so they are occupying the same habitat and they're developing traits in response to these interactions that are happening with these other plants and animals, over time they become quite dependent upon that environment. So if you take a forest edge species like an apple tree, for example, and you take it out of that environment and you put it in quite an alien environment, a grassy paddock, it's not going to like that, because the environment in the soil and the environment surrounding it and the other plants is not going to be an environment that it has adapted to and prefers to live in. So when it's sending out its roots and it's trying to live in this environment, there's none of these beneficial interactions with other forest plants. There's no protection from the elements, or creating mulches in the soil, or recycling nutrient through food chains. It's living in quite an alien environment here. And that's going to create stresses to that plant, which will diminish its production. So it becomes stressed, its yield or its production is reduced, and it becomes more susceptible to diseases, so it's vulnerable to diseases and pest attack. So while it's the healthier it is, the more resistant it becomes to pest attack, and the less it's actually going to be even subjected to pest attack in the first place, because it's one of many in a diverse system. So the pests will be kind of evenly spread out through the system, and there'll be various predators of that pest, and there's a variety of food sources. So pests don't have the same impact within this kind of system, because it's so diverse and it's got so many interacting elements that moderate that system and keep it in balance. But as soon as you take out all of these interactions, you make any individual element a lot more vulnerable to diseases and pests, because it hasn't got all those checks and balances in this more diverse system that help create that balance. So by creating conventional orchard systems that we tend to do, are rows and rows of apple trees in a grassy paddock, or even a paddock that's been sprayed by various herbicides to eradicate any living ground cover at all. You create within that environment a condition that's quite alien to those trees, and is going to reduce its health and make it more dependent upon various sprays and chemicals to support the production. So you're actually creating an environment that creates a negative feedback loop, because it requires more and more input, because the quality of that system becomes poorer and poorer over time. So the fertility of the soil becomes poorer, the biological systems within the soil becomes poorer. There's no checks and balances within these various interactions between the organisms that it would like to share its environment with. So it becomes more vulnerable to weather and pests and diseases. So it becomes quite a challenging environment for these crops to live in, and one only possible through a great input of all these chemicals. But the negative feedback part is that the more of these chemicals you add to that system, the poorer that environment becomes, the more poison that environment becomes. So anytime you add like a herbicide, you are adding poisons into that system that are going to have a greater negative impact on the soil microorganisms. So the more pesticides and herbicides and fertilizers you add to this, the more chemical toxins you're adding to the system that are going to further and further diminish it, and not only diminish all the good properties of the soil, but attract into the soil all the pathogenic bad microorganisms that are going to infect your crop, and consequently increase the rate at which you need to spray fungicides and things to kill these microorganisms in the soil that you don't want to have in the soil, because that whole soil ecosystem is out of whack and become dysfunctional, and doesn't have a beneficial range of microorganisms anywhere. It tends to attract pathogenic ones. So what we need to do is work with either a redesign of the system or a retrofit of the system to make it more aligned with the type of system that these plants would like to live in. So that's the objective of a permaculture orchard design. It's to either, how can we take the system, simplify it, replace species with ones that are going to be most beneficially productive to us, and or how can we retrofit a system and incorporate more of this complexity to help stabilize and diversify the system and reinstall the processes which are going to improve the soil quality and allow the system to become more self-sufficient and resilient over time, and therefore require less input of resources from us. And if we get this right, these systems will become more agriculturally productive and economically more viable, because they require fewer and fewer resources over time as they increase in complexity and diversity and maturity. And because they're often perennial systems, they become more productive because they get bigger and they produce a higher yield up to a certain point where you've got to have the next generation come through to replace the aging generation of trees.